Hello and welcome to my second PAT video. In this video, I'll be covering the elementary mathematics portion of the syllabus.
Hi, this is editing me from the future. You'll see me pop in a few times in this video, but I'm just here to say that I am skipping through the arithmetic section of the syllabus because you all know how to add.
So for geometry and coordinate geometry, I kind of bracketed this under one topic because it's all very similar. But essentially, geometry is dealing with shapes and coordinate geometry is dealing with shapes in the context of a graph, essentially. So in this question, we're asked to find the ratio of the area of the circle to the area of the rhombus in terms of A and B. So that implies that we need to know the area of the rhombus and the area of the circle. So I've just worked out the area of the rhombus quickly here. If you're struggling with the area of a rhombus, you can do it in the way that I've done it here, where I've split it into 4 right-angled triangles. So the area of the triangle here is A over 2, which is the length of the left side, multiplied by B over 2, which is the length of the bottom side, and then times a half because it's a right-angle triangle, not a square. And then for the area of a circle, we should all know that it's pi r squared. But the issue is that we don't know anything about r at the moment. So we need r in terms of a and b because we want this ratio expression in terms of a and b only. We can't have r. So we need to find a relationship between r and a and b. And to do this, I think the best point to look at is this point here, which is where the circle and the rhombus intersect. So something we know about this point is that because it's only touching the circle in one location, that is a tangent, and that angle there must be 90 degrees, as I've put down here. And we know that this length is r, the radius that we've called r. We know that this length at the bottom is a over 2, and this length up here is b over 2. And then we also know that this angle in the corner is the same as this angle here. And then over here, I've just briefly explained that. So if we just say that this angle here is some arbitrary theta, but we'll pretend that we know what it is, and then the rest of these, we say we don't know what they are. So A, B, and C, we don't know. We can say that theta plus A plus 90 is equal to 180 because all the angles inside a triangle need to add up to 180 degrees. And then next, I've rearranged this to get, oh no. So then I rearranged this equation here to get theta plus A is 90, and then theta is 90 minus A. And then using this corner here, we know that the total of the corner is 90 degrees because it's a right angle triangle by there. And we know that because this is a right angle triangle. So we can say that A plus B is equal to 90. And then if we rearrange this, we can see that B is 90 minus A, which is the same as what we have up here. So B is also theta. We have 2 right angle triangles, so we can use our SOHCAHTOA to say that the hypotenuse, which is A over 2 for this triangle here, times sine theta, so that theta there, is equal to r. And then we can do the same thing for this larger triangle and say that b over 2, which is this length here, the hypotenuse, times cos theta, and relating to this theta here, is equal to r. And now an important equation that we need to keep in mind is sine squared plus cos squared equals 1. And then if we rearrange these for sine theta and cos theta, and then square them both, we have the appropriate constituents for this equation here. So down here, I've stuck those in, said that that's equal to 1, rearranged to get an expression for r squared. And obviously for our area of a circle, we needed pi r squared. So we can just pop that r squared in here to get this. And we worked out the area of the rhombus earlier. So to find the ratio, we just divide one by the other. So we wanted the ratio of the area of the circle to the area of the rhombus. So that way around. So if we want ratio of this to that, that is the same as this over that. So we want the area of the circle divided by the area of the rhombus. Just sticking that in. I'm sure you know that if you're dividing by a fraction, you can multiply by the reciprocal of the fraction. That'll just simplify the maths a little bit. So this is a coordinate geometry question where we are talking about two circles, and we want an equation that will describe a straight line between the centers of these two circles. So I'm sure you've gathered a useful bit of information that we need is the center of the circles. So we will need to complete the square. So I've just done that here. I trust that I don't need to talk through completing the square. And then this tells us that the center of this circle that I've called C1 is -2 + 1. And then the center of this circle that I'm calling C2 is +2 + 3. And our radius is √4. And then the other radius is √16. But in this question, we don't really need to know anything about the radii. So at this point, it would be useful to draw a plot of our points, but we're only really talking about the center of the circle. So I've not plotted the whole circles, I've just plotted their centers. So over here we have C1. No, sorry. Yeah, over here we have C1, and over here we have C2, or the center of C1 and the center of C2. And then here is our line connecting them. And I'm sure you know that the equation of a straight line is y = mx + c. So we need to know what the gradient is, and we also need to know what the y-intercept is. So if I start with the gradient is the change in y over the change in x of our line. So the easiest way to work that out is to take 2 points in our line. What 2 points do we know? Center 1 and center 2, or as I've called them, C1 and C2. So we just need to find the change in the y's of them. So these are the y values. And we need to divide them by the changes in x, so these values. And we end up with a gradient of half. The next thing we need to do is find the y-intercept. And I'm sure at this point it would be a real temptation to say, well, y is half x + c. And well, our y-intercept happens when x is 0. So we'll just put this as 0, but you'll just end up with y as c, which is not useful. So what we need to do is we need to use the gradient that we just worked out, but take it to be between these points instead. So our 2 points that we are referring to will now be C2, and I'll call this C0, or just C origin, I suppose. So if we say that the gradient is equal to yc2 minus y0 and xc2 minus x0, and c2, just as a reminder, was 2, 3, and c0, 0, c. Then we can stick these into our equation and say that it's equal to half because that was the gradient that we just worked out. Rearrange these, and then we end up with our y-intercept as 2. And then we can stick both of these values into y equals mx plus c, where this is our m and this is our c. And that is our equation. Okay, so the next topic is probability. These questions, some people find them really intuitive and some people don't. I am certainly not someone who finds probability questions intuitive, but these questions don't tend to be too difficult. You just have to make sure that you present your information clearly to yourself so that you know what everything means. And yeah, just make sure you get the head around the question and what it's saying. So this question is saying that there are 50 people in a room. 8 people in the room have red hair, 3 people have black hair, and 20 people are male. So if you imagine a room of people, it is possible to have males with red hair and black hair. It's possible to have females with red hair and black hair. So the question is telling you that the hair color and the gender are independent. So it's asking, if a person is selected at random from the room, what is the probability they will be a female with red hair? So the first thing that I did was I kind of bonked the information into a more clear and understandable way. So I'm saying the probability of having red hair would be 8 out of the total, which is 50. And then the probability of having black hair would be 3 out of the total 50. And then I've also just said the probability of having some other hair color would be the rest. So 8 plus 3 is 11. So that means 11 people have either red or black hair. So the rest of the people, the other 39, will have some other hair color. So 39 out of 50 will have some other hair color. And then we also know that there are 20 males in the room. So I've said the probability of being a male is 20 out of 50. And then the rest of them should be female. So that means there are 30 out of 50 females. So the first question is asking, what is the probability that they will be a female with red hair? So that means they're female and they have red hair. And if you remember from stats and probability in school, to say this and will be a multiplies, and then if you have an or, that will be a plus probability. So here we have and, which would be multiplying your probabilities. So 30 over 50 for being female, and then 8 over 50 for having red hair makes the probability
12 out of 125.
Okay, so the next question would be, if a person is selected at random from the room, what is the probability that they will be a male who does not have red or black hair? So this is another and probability. We're saying that they're male and they have some other hair color. So again, that's another multiplication job. You multiply the probability of being male by the probability of having some other hair color. And that's your answer. That's 3 marks. Right, okay, so this next question is similar. We need to present our information clearly. So the question says, person A is busy for 50% of the week, person B 75% of the week, and person C 20% of the week. If a time for a meeting is picked at random, what is the probability that A, all 3 are busy, and B, all 3 can't attend the meeting? So again, we just want to write out our information clearly. So the probability of person A being busy, and bear in mind this is busy, not free. So person A is busy, it's 0.5. Person B is busy, 0.75. And then person C is busy, 0.2. So our first question asks what's the probability of them all being busy? So this means that person A and person B and person C are busy. So again, like the previous question, we just multiply these probabilities together. And then the second part is asking for the probability that all three can attend the meeting. So in other words, that none of them are busy. So this says that person A is not busy and person B is not busy and person C is not busy. So we multiply the not probabilities, so the probabilities that they are free. So the probability that person A is free would be 1 minus 0.5 because it's a binary choice, so either busy or free. And then person B, the probability that they're not busy would be 1 minus 0.75. And then person C, the probability that they're not busy would be 1 minus 0.2. And that is our answer. We just multiply these three together. Okay, so the next question is asking about a game of dice. Now, this question had some people had different ideas about this question from looking online. And I think as long as you explain yourself clearly, you're probably fine. But the question says, in a game of dice, a player initially throws a single die and receives the number of points shown. So they will get 1 point, 2 points, 3 points, 4 points, 5 points, or 6 points. If the die shows a 6, the player then throws the die again and adds the number shown to his or her score. So they roll a 6, then they can roll it again, and then they can add that score on who they are on. The player does not throw the die more than twice. Calculate the probability that the player will gain an even number of points. So I think the easiest way to visualize this question is to write out all of the possible results that you can have. So all of the options are they roll a 1 and they get a score of 1. They roll a 2 and they get a score of 2. They roll a 3, get a score of 3, a 4, score of 4, a 5, a score of 5. And now different options happen when they roll a 6. So they can roll a 6, but they can't roll a 0 on their second one. They can only roll some value. So that is shown on a dice. So they can roll a 6 and a 1 to get a 7. They can roll a 6 and a 2 to get an 8. They can roll a 6 and a 3 to get a 9, a 6 and a 4 to get a 10, a 6 and a 5 to get 11, and a 6 and a 6 to get a 12. Now, the discrepancy in the answers of this question comes from the interpretation of the player does not throw the die more than twice. Some people read that as a rule of they get a second throw and that's it. And some people read that as, well, this particular player didn't roll more than twice. And if you read it the second way, that would imply that you don't get this 6-6. But I just think as long as you're clear about which interpretation you had, then you should probably still get the marks. So don't concern yourself too much on small details like that. But for the sake of this question, I will assume that it is in the rules that they don't throw the dice more than twice. They can't be in an infinite loop of 6s. So next, I've just written down the probability of getting each of these. So the probability of the first one would be 1 in 6. And the rest of them up to 5, you have a 1 in 6 chance of rolling a 5. Now for these 6 and somethings, you have to use your stats hat again, where you have a 6 and a 1. So that means you multiply the probability of having a 6 and the probability of having a 1, which is 1 over 6 times 1 over 6. And you should end up with 1 over 36 as your probability for 6 and 1, and for 6 and 2, and for 6 and 3, etc., all the way up to 6 and 6. And then I've plotted our whether our outcome is even or not. So we can see that it's even when we roll a 2 or a 4 or a 6 and a 2 or a 6 and a 4 or a 6 and a 6. So it was asking what the probability that the player will gain an even number of points is. So what we're saying is the probability of getting an even number is the probability of getting a 2 or 4 or an 8 or a 10 or a 12. So our ors were pluses, and we have the probability of getting a 2 is 1 over 6, plus the probability of getting a 4, which is 1 over 6, plus the probability of getting an 8, which is 1 over 36, plus the probability of getting a 10, which is 1 over 36, plus the probability of getting a 12, which is, again, 1 over 36. And then that would make our total 15 out of 36. So next would be questions on polynomials. So a polynomial equation is one where your unknown, so this could be x, is raised to a power greater than 2, I suppose. So x cubed plus x squared plus x plus 1 is a polynomial. The power of 2 would be a binomial. Most of these questions want you to work out what the roots of these equations are. And if you remember what a root is, that's essentially all the places where your graph hits y at 0. So this thing that I've drawn here has 1, 2, 3, 4, 5 roots. So in this question here, they have given us a polynomial, x cubed plus 2x squared minus 5x minus 6 is equal to 0. So that would be some kind of an x cubed graph like this. And they want to know what these 3 roots are, given that they've given us 1, which is helpful. So the first part of the question is to show that x is minus 1 is a root. So essentially what we're saying is we want to show that when x is minus 1, our equation x cubed plus 2x squared minus 5x minus 6 is equal to 0. So we can literally just plug that into the question for that to show that that is true. So here you can see that I've done that. The next part of the question is a little bit more interactive. For this, we need to find out what the other 2 roots are. So it's helpful here that they've already given us 1 root, because we can say that x plus 1 equals 0 is a factor. So x plus 1 is a factor of this equation. So we can factorize this equation here by popping the x plus 1 in its own little bracket on the outside. And then we have to say that the leftover, and then we have 3 unknowns in the leftover, which I've called alpha, beta, and gamma. And in order to find out what these leftovers are, then we use the coefficients, or we try and match the coefficients from this unknown equation to this known equation. So the first one I'm going to look at is the x cubed coefficient. So I need to look at this and decide which x's in here will multiply together to make an x cubed coefficient. Well, I can see that this one and this one are the only ones that will multiply together to make an x cubed coefficient. So we can say that x, this x here, multiplied by alpha x squared must be equal to this x cubed on this side. So alpha x cubed must be equal to x cubed. And the only way that can be true is if alpha is equal to 1. Then we'll do the exact same thing for the x squared coefficient. So what values in this equation here will make x cubed, the x squared, sorry. Well, we know that if we multiply this x to the power of 1 by this x to the power of 1, we'll get an x squared value. And if we multiply this x to the power of 0, technically, with this x squared, then we'll also get an x squared. So we can say that 1 times alpha x squared plus x beta x from this second part is equal to 2x squared from this side. And then if we stick in our alpha from earlier and rearrange this, we can get beta is 1. Then we have a choice for this last one. We can either look at the coefficients of x by itself or x to the power of 0. Looking at the coefficients of x to the power of 0 is the easiest option, but I will show you both because it's useful to use one as a check for the other to make sure you've got the correct answer. So if we're looking at the x coefficient, the things that will make a singular x would be this x and this x to the power of 0, and then this 1 and this x. So we can say that 1 times beta x plus x times gamma is equal to the minus 5x from this side. Then again, we can stick in what we know. We knew that beta was 1 from the previous question, the previous coefficient. And then we can rearrange this to get that gamma is equal to minus 6. And if we just check with the nothing coefficient, well, the only thing that's going to make an x naught on this side is this times this. And then our x naught on this side is minus 6. So 1 times gamma is equal to minus 6. So we can see we have the same answer here. Next, what we want to do is we want to stick what we've just worked out here, so the alpha, the beta, and the gamma, back into our standard equation that we created up here, so that we can see what this looks like in numbers. So if we stick in our alpha, beta, and gamma, we have alpha is 1, so we have just x squared, beta is 1, so just an x, and then gamma is minus 6, so minus 6. And then we can factorize this second bracket to find out what our other roots are. So we factorize it to get x plus 3 and x minus 2. So that means that our roots are x equals 2 and x equals minus 3. So we can say x plus 3 is 0, so x is minus 3 as a root. And x minus 2 is 0, so x equals 2 is a root. If it wasn't clear how I got 2 and minus 3 rather than minus 2 and 3. Okay, so this is another polynomial question, a slight step up from the previous one, as we have an x to the power of 4 term, and our factor that we know this time is a binomial equation itself. So the first, all it wants us to do is to find out all of the roots. Well, from this factor here, we can already just pretty much straight away work out 2 roots. So if we factorize that, we can see that we get x minus 3 in one bracket and x plus 2 in another bracket. So our roots are x equals 3 and x equals minus 2, which is funny because it's the opposite way around to the previous question. They're unrelated, but I just thought it was quite funny. Okay, so if we go about a similar method to last time, we can say that x squared minus x minus 6 is a factor of that. So if we take the x squared minus x minus 6 out, we're left with some unknowns inside that bracket, inside the second bracket, like we did last time. And the reason I know that the order of this bracket is x squared x x naught is because in this equation, x4 is our largest power. And in this factor, x squared is our largest power. So if we multiply out this x squared minus x minus 6 with, or say x cubed plus x squared plus x plus 1, and just some arbitrary terms in front, pretend that I wrote this in. Then when we multiply this first bit out, we'll end up with an x5 term, which doesn't exist in our equation. So this power here is capped at x squared, essentially. Otherwise, we'll end up with terms that don't exist, or just zero coefficients, which are pointless. So similar jam to last time, we look at our x to the power of 4 coefficient first. So our highest x coefficient. So we can see that x squared and alpha x squared can multiply together to make an x to the power of 4, and no other combination can. So again, we end up with our answer straight away without having to sub in any known information. Then again, we do the same thing with x cubed. So the only things that will multiply together to make an x cubed is this x squared and this x, and then this x and this x squared. So same jam as before, add them together and compare coefficients. So we have beta is 5. Then looking at our x squared coefficient. For this last one, we only have one unknown left. So we can look at the x squared coefficient, or the x coefficient, or the x naught coefficient. So I've worked out the x squared coefficient for you, but again, the x naught coefficient is the easiest one because you don't need to sub anything in, but it was a good check to make sure that I got the same thing. So for the x squared, we need to look at what combinations will make an x squared. So this minus 6 and this alpha x squared will, this minus x and beta x will, and then this x squared and this gamma will. So you can see we have quite a few things to plug into the equation this time. So it's definitely easier to just look at the x naught coefficient here. And then as we did last time, we just stick those values that we worked out back into our second bracket. And then we can factorize that second bracket to get the last two roots. So this next topic is graph sketching. And I'm sure you will have covered a lot of techniques for graph sketching in school, but I'll just run through a couple of different question styles relating to graph sketching. So this first one is more of a sinusoidal graph sketch. And it asks us to sketch the function y equals 3 plus 2 sine in brackets x minus 3 outside the brackets pi over 3 between these two values. So there are kind of several ways you can approach this question, but one approach is to break up this equation into more intuitive sections. And also remember this question's in radians. My first step here was to draw a sine, just a sine graph. So that would be just kind of looking at this portion here, pretending that what's in here doesn't exist. And you all know what a sine graph looks like. Then we have a look at what's inside the brackets. And the things that are inside the brackets only affect the x-axis, and the things that are outside of the brackets only affect the y-axis. Oh yeah, it's worth mentioning, I simplified what's inside the bracket here as well, just to make it a little bit more understandable. But for here, we're saying that we're shifting the graph to the right by pi. So I've just done that on my sketch here. I've shifted the sine graph over to the right by pi. Then next we look at what happens when we multiply the x values. When we multiply the x values by pi over 3. So what that will do is I find the best way to imagine this kind of like inside outside of the bracket. What's it doing is like I said before, what's inside the bracket affects the x-axis, what's outside the bracket affects the y-axis, and what's inside the bracket does kind of the opposite to what you'd expect, and what's outside the bracket does what you would expect. So, for example, this is minus. It doesn't mean it's moving to the left. It does the opposite to what you think. It moves to the right. And this is multiplying x by pi over 3. So what that will do is, since pi over 3 is a number larger than 1, you would imagine that would enlarge the space between the x values, but it actually does the opposite. It divides all of your x values by pi over 3. So you get a more squished kind of graph. Then the next step is we look at what's outside the bracket here. So we look at this too. And what that's going to do is it'll double all the y values so that you get these at double the amplitude, like that. And then finally, this plus 3 shifts that graph up 3 spaces. So I also decided to kind of look at this, or show a more kind of intuitive way of working this graph out, because I understand that this method here, especially with the pi x over 3 part, doesn't really help you imagine how the values have moved and how these points are on the 3, 6, 9, 12 points. So different way of looking at what's happening on the x-axis is to say, well, we know that sine x is 0 when x is 0, pi, 2 pi, etc. So we know that when this part inside the bracket here is equal to 0, pi, 2 pi, etc., then the graph is going to be 0. So we can say that when this is equal to that, our graph hits 0. So when x is 3 times some value, so 0, 1, 2, 3, or minuses as well, plus 3, then our graph will hit 0. And then outside of the bracket tells you about the amplitude. So this here is what tells you that your graph will be 0 or, well, 3, I suppose, when we've shifted it up. But imagine this before we've shifted it up. It tells us that we'll have these values at 3, 6, 9, and 12. Okay, so this is another example of a graph sketching question. I feel like this one is quite standard, and you've probably done a lot of similar ones in school, but it's definitely one to get used to practicing, and it just kind of follows the general method that you would expect. So the first thing I did, and I think is always worth doing, is to check where your asymptotes are. An asymptote is I'm sure you already know, is a point on the graph where your graph will never actually meet that value. It'll tend closer and closer to it, but never actually cross that value. So typical places where that happen are if we have something on the bottom of the graph. When that's 0, it'll drive this to be infinity. So as x squared approaches 0, then y will approach infinity. But obviously, it can never actually reach infinity, so it never actually reaches 0. And then the next asymptote that I like to look at is to say, okay, well, if x is getting bigger and bigger and bigger, what's happening to y? I find the easiest way to envision what's happening here is to break this up into the 3 constituent parts. So we know that 1 minus x squared all divided by x squared is the same as 1 over x squared minus x over x squared minus x squared over x squared. So we can simplify it to look like this. And then if we tend x to infinity, what's going to happen to each of these fractions? Well, this first one here, as x gets bigger and bigger and bigger, then this fraction will tend to 0. And then for the second fraction, as x gets bigger and bigger and bigger and bigger, the fraction will get smaller and smaller and smaller and will tend to 0. And then this fraction here, the x squareds cancel to give a -1. So as our x goes to infinity, our equation here, our y, will tend to -1. So that gives us two asymptotes. X is 0 and y is -1. Okay, so the next thing I'm going to do is I am going to find out where on the graph y is 0. So where on our graph will we get some points like this? So y is 0 when this top portion is 0, because 0 divided by anything is 0. So we want to say when 1 minus x squared is 0, y is 0. So we're going to want to factorize that. And then you get your values to come out to this funky little thing here, which I use a calculator for this. And it occurred at x is 0.62 and x is -1.62. So I've plotted those on the graph by here. And at this point, I can see that it would be super, super tempting to just say, oh, well, we have asymptotes here and we have asymptote here. So it's going to look like this. But at this point, we haven't actually got all of the information because these aren't the only options of things that can happen. Though we say we never reached this value here, we can still cross that value. So you could end up with something like this, or like this, but we don't know that yet. So the best way to find out if anything like that happens is to look at the maxima or minima. So in order to do that, we're going to have to put our calculus hat on. If you've not studied calculus in school yet, I'm really sorry, I'm just going to assume calculus knowledge here. But in order to find the maximum or minimum, we need to find where the gradient is 0 or where the first derivative is 0. So here I've just taken my first derivative. Different notation. The first derivative can be dy by dx, or if you're lazy, you can just say y prime. So here I was lazy and I wrote y prime. And then I've rearranged this to get a value for x, which was equal to 2. So we know we have some kind of a maximum or a minimum here at x is 2, but we don't know where along that line that is. So it could be down here, it could be up here, and then depending on where that is, it will change our graph dramatically. So we need to work out what the y value associated to this x value is. So at x is 2, we stick that back into our original equation, the y equals 1 minus x squared over x squared. And then we get that to be -1.25. So we know that our minimum is going to be somewhere about here maybe. And then at that point, we have enough information to fill in our graph. So in order for it to go through this point, well, we only have one minimum, and that's down here. So we can say there are no maxima or minima that side. And then on this side, this is a minimum. So we have to go like this. Now, if you're not sure if your point at x equals 2 is a maximum or a minimum, you have a choice of two things. You can either take the second derivative and then pop x in and see if that's positive or negative, or you can just plop in a couple of points either side of x equals 2. So say pop in x is 1.9 and x is 2.1 and see if they're higher or lower than -1.25. In this case, they should be higher than -1.25 because it's a minimum. And that'll just give you an indication of whether it's maximum or a minimum without too much calculus. Okay, this next question is slightly different. This one isn't looking for a specific graph exactly, it's looking for us to understand what different elements of a graph actually mean. Namely, the term continuous, and it wants us to understand what the first and second derivative actually tell us about a graph. So in this one, I think the most obvious thing that we see, that df by dx is 0 when x is 4. So that tells us that x is 4. There is either a maximum, a minimum, or a point of inflection. And if you're not sure what that means, this would be a maximum, this would be a minimum, and this is a point of inflection. And don't forget about points of inflection. But in order to work out which one of these it is, then we need to look at the rest of our information. So A tells us that f of x is always greater than 0. So if we look at these different points up here, this first one suggests that at some point it's going to get smaller and smaller and smaller, and it will have to cross 0 at some point because it's continuous. Obviously, if we had something like this, it would be fine, but we can't have something like this because it's continuous. So we can rule out it being a maximum. And if we look at this second point, minimum, that seems fine because as long as our minimum is above 0, then it'll never cross 0. And then this third one, the right-hand side is fine because, again, as long as our point of inflection is above 0, then we're fine. But this side will cross 0 at some point. So it can't be a point of inflection. It has to be a minimum. So next what we're told is that d to f by dx squared is 0 at x is 2 and x is 6. So this is useful information because our second derivative tells us something about our stationary point, essentially. If it's positive, then it's a minimum. If it's negative, then it's a maximum. And if it's 0, then it's likely to be a point of inflection. So that essentially tells us that at x is 2 and x is 6, we have a point of inflection. And now we have all the information that we need to draw a graph. So as long as this is above 0 all points, we have points of inflection at 2 and 6 and a minimum at 4, then we satisfy all of the conditions. And I'm just assuming that it's continuous as long as we don't go like something like this or something like this. Then it's continuous.
Hi there, this is Angharad from the future. And after editing this video, I've realised that it's an hour and 25 minutes long. So in order that you are not sat there for an hour and 25 minutes watching this one video, I've decided to split this into 2. So this is the end of part A, and I look forward to seeing you in part B, where I'll be talking about the rest of the things on this portion of the syllabus.